The following video is the Zoom presentation of a recent MassDEP UMass Drinking Water Small Systems intern project on remote services by Marie Rausch and Isaac Reyes. The MassDEP UMass Small Systems intern program is funded by a U.S. EPA Safe Drinking Water Act grant to MassDEP in support of small drinking water systems throughout Massachusetts. This collaboration began when MassDEP's Yvette DePisa, Michael Maynard, and Art Screpitus saw opportunities for drinking water community involvement and operator trainings with students of UMass under the leadership of Professor David Reckhow and Professor John Tobiasen, along with research engineer Patrick Whitbold. Previous intern projects have worked on lead in schools, small system assistance, operator certification, and other current drinking water topics such as PFAS. MassDEP would like to thank all of our partners on these projects, including the U.S. EPA, Mass RWA, FERCOG, RCAP, and the UMass Group, especially Professor Reckhow, Patrick Whitbold, and the student interns. They've done hard work on this and all their other drinking water projects.
All right, well, hello, my name is Isaac.
And my name is Marie.
And today we're going to present with you guys our research that we've done on remote services.
So due to the COVID-19 virus, our country has been required to work remotely or as remotely as possible. And while some of our water facilities do have remote capabilities, many others do not. This has kind of forced us to reevaluate our water systems and ask ourselves if they're still set up to function most efficiently, even with reduced staff. This could be a rough transition because many people aren't comfortable with the technology used for remote work. And even though COVID-19 has provided this initial pressure for us, we were also looking for the long term to see if remote services is something that can improve our water systems even when we could return to normal work. So this is a brief outline of what we'll be talking about today. We'll talk about how we broke up remote work. We'll then be evaluating potential pros and cons and sharing our conclusions.
So first things first, what exactly does remote work entail? So we decided to break it down into four main aspects, being communication, security, inspection, and operations. Why did we pick these four? So when we began this project, we initially focused on the inspection side of things, because inspections were the primary way to evaluate a water system's effectiveness. And this quickly led us to operations, since in a remote working world, inspections and operations will have to be closely related. Digging deeper into those areas, we realized that communication is going to be a vital foundation for remote services of any kind.
Someone's microphone is on. Sorry, guys. Bob Hoyt, I'll mute him.
And once we looked into communication, we kind of realized that a bigger concern is going to be security. So with the introduction of new devices and new systems, also creates new potential openings for cyber attacks that we may not be ready to deal with. So in a world of a remote work, the way we communicate will have to change, from in-person meetings to group video calls like the Zoom call we're on now. And with the transition, there are going to be plenty of challenges, a major one being how do we maintain a secure method of communication. Looking at the short term, the social distancing guidelines have forced many of us to learn and adapt to new methods of communication like Zoom. Honestly, before the pandemic, how many of us ever used or even heard of Zoom? And as a result of this rush transition, there hasn't been much time to develop any regulations for these methods, which is why in the long term, we need to develop standardized methods for these new forms of communication. So focusing on communication, we broke it down further into two subcategories, people and devices. People such as your fellow coworkers, supervisors, and clients, and devices, meaning things like your phone, remote alarms, etc. And the reason we broke them down into further categories is because the methods we use to deal with these will vary greatly. So here are some examples of the tools that can be used for each category. For people, we have things like group meeting platforms like Zoom and file sharing tools like Dropbox and Box. And for devices, we use things like we use things like your phones, monitors, and especially cameras. Where those two categories intersect is going to be in terms of the protocols used to standardize them, SOPs, and regulations. And we mentioned cameras earlier, and we wanted to give special focus to these, since in a remote working world, cameras are going to be very vital to remote communication. And that's because pictures and videos provide a relatively unbiased source of information with which people can develop their own thoughts and concerns. We also wanted to mention that there are various types of cameras, so it's not just going to be as simple as going into Amazon and buying the first camera you see. You need to buy the camera that addresses the needs of a particular system. And wrapping all this up, we also need to look at the security side of things. So the main concerns with security aren't whether or not if we have enough security. Water systems are essential to the health of the public and the environment, as I'm sure you know, and as such, they're protected by agencies like Homeland Security. Our main concern comes from a lack of knowledge on how these new technologies work, and just from people being uncomfortable with it. So here's a table of some common preventative security measures, and we believe that every remote system is to be implemented. At least one of these should be used to help provide some sense of security.
So again, we chose to talk about inspections and operations because they're a huge part of the water industry. Their work is most directly impacted by the reduction of face-to-face interaction, and as a result, they had to completely reevaluate how they do their work on a day-to-day basis. So a standard operating procedure, as many of you know, is a formal or regulated guide on how to do a process. They can be implemented via email or online searches. But that being said, not all of Massachusetts has equal access to internet service. The map on the top of the screen shows Verizon service lines. As you can see, around the Boston and Central Mass areas, there's more service available than in Western Mass. So we want to remember that not all of our water facilities have the same resources, and we need to take that into account when writing SOPs. So we decided to break SOPs down into two different subsections: inspections with internet and without internet, from both the operator and inspector's perspective. On the next slide, I'm going to break them down for you. So prior to the inspection, the operator should send records to the inspector, such as data logs, and make sure that their camera works. This is probably new technology for a lot of people, so making sure that they understand the system prior to the inspection is going to be important. The inspector should send the operator an SOP just in case the internet fails. This is worst case scenario, but having a backup plan in place is important so that the inspection can still be conducted even if the internet fails. To prevent missing anything that might be deemed important, the inspector should also use information sent by the operator to create a plan of what they want to see. And many experienced inspectors have already been to the facilities in their region, so they can use their background knowledge as well. During the inspection, the operator and inspector will connect via a platform and run through the facility through the inspection. If they find any problems, they should decide the severity while they're still on the phone. They might need to call in a third party to help or find other resources. I say to do this over the phone because emails tend to take some time to respond to. If we have a lot of them, obviously it can be hard to get to it in time. And post-inspection, the operator should send any other information to the inspector that may have been missed the first time around, such as pictures of certain parts of the facility or other data logs. The inspector will use all of this information to write up a report. For operations, we do have some current remote systems. As some of you may know, systems employ the use of programmable logic controllers, or PLCs. These are the systems that are the brain behind the system as a whole, and they can be used to adjust sensor alarm levels, dosing, timing, and things of that nature, but really only by a programmer. Operators can interact with the PLC through a human-machine interface, or HMI. HMIs allow the operators to manually control different components, such as valves, and allows them to monitor the system. There are various computer applications that can allow operators to access and interact with the HMI remotely. The problem that we may run into, though, is that these remote systems were never the primary source of analysis, and now they'll have to be. Operators are not used to relying so heavily on these remote systems, so when we do come to a solution, we need to keep in mind that there will be inexperience and discomfort from the operators on relying on these systems.
So that said, we were fortunate enough to be able to interview 3 people who are working or have worked with MassDEP and get their insights and opinions on remote services. So we wanted to share 2 key questions we asked them and their overall opinions on them. So first, we asked, is the implementation of a remote system even possible? And every person we talked to felt that remote services, particularly inspections, could be done remotely and that it can be beneficial to some degree. However, there was a spectrum of opinions to the extent of this. Some felt that it could completely replace the way things are done, while others felt that it should only be implemented as a tool and can't replicate the quality of a in-person inspection. For example, remote systems could be used to make follow-up inspections easier and more convenient to do, as opposed to becoming the primary method for inspections. Also, while this, we were also reminded that while the technology today is capable of maintaining such a system, the infrastructure still isn't there. So looking at this picture from earlier, we just want to reiterate that not all parts of Massachusetts are created equal in regards to service. And as such, it'd be very difficult for systems in these regions where small systems are commonly found to maintain a fully remote system. Next, we asked, what does the inspector need to make remote inspections possible? And it boiled down to these big 3 points. 1, the inspector needs to show up for the remote inspection with an idea of what they want to see. They should know what areas of the plant needs to be focused on, what questions need to be asked, and which components need to be seen. 2, the operator who is assisting the remote inspection needs to have all the necessary paperwork readily available. You don't want to be wasting time digging through files to find documents. All that time could be better used elsewhere in the inspection. And 3, all the important people that are relevant to the inspection process should be there. That way there's minimal lost time due to back and forth communication like via email, and any questions or concerns that come up can be addressed right away. For example, when working in small systems, having the owner of the system there may be a good idea.
So now we're going to talk about costs and benefits. There are some initial costs for implementing operational remote systems. First, you have to buy and install a new operational system and also maintain them. And in many cases, this includes maintaining a good Wi-Fi service. There would also be personnel training on how to use the systems and how to use them efficiently. And there would also be a loss of on-site experience from both inspectors and operators. As the newer generation comes into the field after remote servicing has started to be implemented, they might not be as comfortable with traditional methods of evaluating a water facility's performance or taking measurements by hand. That being said, there are benefits. For inspectors and operators, there are decreased costs, which come from more efficient systems. As many of us know, operator numbers have been in decline the last few years. So this is a good opportunity to get people into the water field and hopefully encourage them to get certified. People with less water experience will be able to assist in remote inspections or operations if they are directly in contact with an inspector or an experienced operator who can walk them through whatever task they're supposed to be performing. This is especially beneficial for small water systems that don't have an operator readily available all the time. And for the public, remote systems should make follow-up inspections easier and more mainstream, which should improve the monitoring of each water system, ultimately offering more peace of mind over the public's water quality.
So we just want to mention that all this sudden need for understanding remote services also created some potential areas of future work. And a few ideas we came up with are pilot scale projects and the creation of some sort of database for operators, inspectors, and public. So for pilot scale projects, that could be implemented such as an experimental setup with remote services, without remote services, and like with partial remote services, see that what impact the remote services has on the effectiveness of that system. This all could be done in collaboration with some smaller plant, which would provide a more realistic in-situ scenario. And as for the database, we briefly mentioned this earlier, that SOPs can be found online, but they tend to be very difficult to find, especially if for newer operators or if you're just not familiar with the language used in the water field. And if we feel like a database would help greatly minimize the waste of time searching for documents in the long run. And in conclusion, we believe that it is technologically feasible to implement a remote system in many water systems, but the infrastructure is kind of just lacking. And as a result, the implementation of remote systems in those areas of local service will be difficult for all parties involved. And finally, it's important to remember that a remote system is not a one-size-fits-all solution. Every system is different, and what works for one system may not work for another. That's all for our presentation. Thank you for your time, and we're happy to discuss any questions if there are any.
Thank you, guys. Very well done. So we'll take 1 minute for questions. I guess it's first come, first serve, so just speak up if you have a question.
This is Kevin Riley with EPA. Did you get a sense from the DEP, or even if you talk with any water suppliers, just how much SCADA or remote access or capability small water systems are actually using now?
So the feeling in terms of SCADA systems, that those are tend to be very expensive systems. So small systems don't usually utilize those. But we kind of got the sense that if a system can use things like internet to assist in their analysis of water quality, they will. But like I said, some of these places don't have that much service, so they don't use too many remote services, things of that nature.
So it's a general sort of, and that's fine. That's a general sort of assumption. I know some, in talking with Rural Water Association, Mass Rural Water, I know some systems do have SCADA capability in monitoring their tanks and that kind of thing. Just trying to see if there is anything more out there that you might have run across from the state and its opinion.
Nothing specific. No, we mostly just looked into like the opinions on whether or not it could be implemented. We weren't able to find too many of the specific things that are being used right now.
Mm-hmm.
Yep, that would be a good question to address if you know, your research continues in a way. To evaluate.
Thank you. Good presentation.
The degree of cost that would need to be added to systems without any sort of SCADA infrastructure or remote monitoring, because the equipment is obviously more expensive for systems that don't have any of it. Okay, time for one more question. Anybody?
Yeah, Bob Boyd here. How you doing, Kevin, by the way? I'm interested in one of the issues I would see. Obviously, the small systems have very little SCADA systems. It's mostly just going to be a visual look. But some of the ones that do have SCADA, one of the issues is how are you going to tie into their SCADA system, because there's oftentimes fairly strict protocol for access out. In other words, getting into a SCADA system as an outside person, you're going to have to get approval, obviously, from the water system, and that presents more liability on the water system.
Great. Thank you, Bob. Okay. Thank you, Isaac. You can stop sharing your screen.